Okay, back with part 2 of 6.1 Maxima and Minimum problems. So I'm just going to go over 2 refresher questions and then we will apply this to a word problem. So what I want you to do here is you want to graph this using the vertex plus 2 other points. So first of all, my vertex here I know is at -4, -2. So if I was to graph it, -4, -2, there's my point. And it's gonna look something like that. It's asking though for 2 other points. So let's find out where this will cross the y-axis. In that case, at that point, x is equal to 0. We want to find the y value. So we're just going to sub that into our equation. Y equals 0 plus 4 squared minus 2. I sub that in for the x. 4 squared is 16, minus 2 is 14. So there we go, it crosses at 14. I need to find another point. I'm going to pick -8. I'm usually going to pick -8 here. I can pick any point, but in this case, I know this is Max's symmetry at -4. Since I picked a point that is 4 to the right, I'm going to pick a point that's 4 to the left, which will be at -8 on my x-axis. So when I sub that in to our equation, -8 plus 4 is -4. -4 squared is 16. -2 is 14. So there's my other point at -8, 14. And that's symmetrical, that makes sense. Picking a point that is, that I think is gonna be symmetrical to this point lets me know that I've done my math properly as well. All right. Here I want to know what is the minimum or maximum value for this equation in standard form. It's probably in standard form. So I'm going to put it into vertex form like we did in the last lesson and find out what my minimum or maximum is. So brackets. Within brackets, my greatest common factor is 1.5 if I look at just the coefficients. 1.5 x squared divided by 1.5 is just 1x squared. 6 divided by 1.5 is 4. And we get this. Our b value is 2. Divide that by 2. 4 divided by 2 is 2. Square it, we get 4. So y equals 1.5 x squared plus 4x plus 4 inside the brackets minus 4 outside the brackets. Perfect squared trinomial, x plus 2 squared when factored. 1.5 times -4 is -6. Carry down the -7. Simplify, we get this. So our vertex is at 2, -2, -13. If we're to graph it, -2, -13, it's gonna look something like this. It's a positive, so it's opening upwards. It's stretched by 1.5. So this is our minimum value. All right, word problem. So for a high school basketball game, you know that 500 people will attend. If tickets are $2. They also, for the championship game though, they want to raise the prices. Want to make more money. Our question is, how much can they raise the prices by in order to maximize profits? So this is going to be a maximize profits question, a Maxima question. So in real life, we see this all the time. You see this when you go to the movie theaters. When you go to the movie theaters, movies are 12, 13 bucks. Popcorn is very expensive. And you might think to yourself, well, if they, lower the price of popcorn, more people will buy popcorn. Absolutely. But that doesn't mean they'll make more money because they're making less per bag of popcorn. So Landmark or Cineplex has figured this out to maximize profits. They know that if they raise the price of popcorn again, less people will buy, but those who are buying are spending more money. So they figure out where their sweet spot is, where they can maximize profits. They don't care about how much popcorn they sell. They just care about how much money they make selling the popcorn. So in this case, back to our basketball game, 500 people will attend if it's $2 a ticket. We know that every time the price goes up by 20 cents, 20 less people will attend. So like the popcorn, if popcorn goes up, less people will buy it, but that doesn't necessarily mean less money. If the price of tickets go up, less people attend. So the revenue, that's how much money they make. Basically, this is going to be price times tickets sold. So revenue is, we know in our case here, the price is normally $2, and the tickets sold is normally $500. So for a regular game, $2 times 500, that would be $1,000 of revenue. Let's factor in our increases. So we know here that profits, the price, write that in, price is $2. Our price is going to be $2 plus 20 cents. And X here is the number of price increases. So price will be $2 plus 20 cents if it's one price increase, so $2.20. If we have two price increases, 2 times 20 is 40 cents, so it'll be $2.40. And so we can add that into our equation here. And we know the number of tickets sold normally is 500, but it will go down 20 for every price increase. So if you have one price increase, it'll go down 20. So 500 minus 20 is 480. Two price increases, it'll go down 2 times 20, which is 40. So 500 minus 40 is 460. So we can build that into the equation as well. And now, let's solve this equation. So the first thing I'm going to do is I'm going to FOIL it out. 2 times 500 is 1,000. 2 times negative 20x is negative 40x. And this, I'm going to skip to the answer. And the answer, of course, has been rearranged when I simplified so that I have an ax squared plus bx plus c standard form. And now I want to find out the minimum or maximum value, so I want to switch this into vertex form like we've been doing all along. So let's switch this into vertex form. Put brackets around here. Let's pull out our greatest common factor, which is going to be minus 4, not 4, minus 4, because we want to get rid of the minus inside the brackets. So negative 4x squared divided by negative 4 leaves us with an x squared. 60x's divided by negative 4 is negative 15x's. And our plus 1,000 on the outside. take our B value here, minus 15 divided by 2 is minus 7.5, square it, and we get 56.25. So R equals -4 x squared minus 15x plus 56.25 on the inside and minus 56.25 on the outside, plus our 1,000. If I factor this out, we get this. -4 times -56.25 gives me a plus 225. Carry down the 1,000. Oops. There we go. And so here our vertex is at 7.5, 12.25. This tells us, so if you want to look at it graphically, 7.5 is here, 12.25 is here, and we have a thing that looks like that. It's stretched by 4, and it's opening downwards. So this is our maximum point, and that's what we wanted, maximum profits. Now on the x-axis here, this would be the number of price increases on the x-axis, and on our y-axis is profits. So we know that if we do 7.5 price increases, that will maximize our profits. We know the initial situation was 500 times $2 a ticket. That would be $1,000. We know that if we increase the price 7.5 times, we'll actually make $1,225. We'll make more money. Less people show up, but the less people that show up spend more per ticket, and so prices go up. Same thing with the movies. If popcorn is $2 a bag, 500 people will buy it. We know that as prices go up, less people will buy the popcorn. However, if in this situation, if these were the prices, we know that if we raised popcorn 7.5 times, less people will buy it, but more profits would be made. So how much should the ticket be? Well, we know that 7.5 price increases. So our initial price equation is $2 plus 20 cents times X, 7.5 price increases, and that tells us that the price of the ticket should be $3.50. That's all we have, ladies and gentlemen. Have a good day.